Welcome to the second episode of Aldehydes and Ketones, which includes introduction, nomenclature and uses of aldehydes and ketones. In the earlier episode, we have introduced aldehydes and discussed a few methods of preparation of aldehydes and ketones, like from oxidation of alcohol. We have discussed the formation of aldehyde and ketones by hydroboration oxidation reaction also. So, in the present lecture, we will discuss first of all what actually are carbonyl compounds, that is, we will introduce them first, then we will discuss the nomenclature of aldehydes in detail, we will discuss nomenclature of ketones, then we will discuss the nomenclature of dialdehydes and diketones, that is the molecules which have two aldehydic group or two ketonic groups. We will then discuss the nomenclature of carbonyl compound having two or more different groups. Then we will discuss the uses of aldehydes and ketones. So, to start with the introduction of aldehydes and ketones. Aldehydes and ketones contain a carbonyl group. An aldehyde contains at least one hydrogen atom bonded to the carbonyl carbon, whereas ketone has two alkyl or aryl groups bonded to it. Two structural features determine the chemistry and properties of aldehydes and ketones. So, you can see here that this is the carbonyl group and this is an aldehyde where carbonyl group is attached to one hydrogen. This is a ketone where carbonyl group is attached to two alkyl groups, which can also be two aryl groups. The carbonyl group is sp2 hybridized with trigonal geometry with an angle of 120 degrees. The molecule therefore is relatively less crowded. The electronegative oxygen atom polarizes the carbonyl group and makes the carbonyl carbon electropositive or electrophilic. As can be seen in this figure, this oxygen is electronegative compared to carbon. As a result, there is development of poles in the molecule, and because of which this carbonyl carbon is electrophilic in nature. We will now discuss the nomenclature of aldehydes. First of all, we will discuss common names of aldehydes. Like carboxylic acids, many simple aldehydes have common names that are widely used. A common name for an aldehyde is formed by taking the common parent name and adding the suffix aldehyde to it. Like for example, this molecule is called formaldehyde because it has been derived from formic acid. Formic acid upon reduction forms formaldehyde. Similarly, this molecule is called acetaldehyde. The oxidized product of acetaldehyde is acetic acid, and this molecule is called benzaldehyde. Benzene ring to which is attached this aldehydic group, and that is why this molecule is also called benzene carbonaldehyde. The IUPAC names of these molecules have been given in parenthesis, and we will discuss in detail IUPAC nomenclature associated with aldehydes later on. For naming aldehydes according to common names, Greek letters are used to designate the location of substituents in the common names. For example, in this molecule you can see that this is the aldehydic group, and next to this aldehydic group, this carbon is called alpha carbon, then beta, then gamma and delta. So, any substitution on this carbon or this carbon will be accordingly named. The common names have been taken from Latin roots, as are the first 5 carboxylic acids like formic acid, acetic acid, etc. Greek letters are used to indicate the position of substituents with the carbon atom adjacent to or bonded to carbonyl carbon. A 5 carbon acid is called valeric acid, and the aldehyde derived from it is called valeraldehyde. As you can see in this molecule, this is a 5 carbon aldehyde. We have 5 carbon 1, 2, 3, 4 and 5, and at this carbon, which is gamma with respect to carbonyl group, has a chloro substitution, and that is why the common name of this molecule is gamma chlorovaleraldehyde. We have in this table given the names of common names of some aldehyde which have been derived from their corresponding acids. For example, you can see here it is formic acid from which formaldehyde has been derived, and formic word has been derived from ants actually. Formica means ants, and actually in ants this formic acid of formaldehyde is present. Similarly, acetic acid, the word acetic has been derived from the word acetum, which means sour, and accordingly the aldehyde called acetaldehyde. In the similar manner, a 3-carbon aldehyde is called propionaldehyde, a 4-carbon aldehyde is called butyraldehyde, and a 5-carbon aldehyde is called varaldehyde. We will now discuss the IUPAC names of aldehydes. For naming a molecule according to IUPAC system of nomenclature, first of all we have to locate the parent compound. Parent compound means we have to locate a compound having longest continuous carbon chain, and the carbon chain must contain the carbonyl group in it. Then replace the suffix E of the parent alkane with al, Al. Number the chain with carbonyl carbon as 1 number and then name other substituents. Like for example, here this is the most simple example where you can see we have only 1 carbon. So, this has been derived from methane, a 1 carbon alkane. Since this aldehyde has been derived from 1 carbon alkane, so what we will do is that we will replace E of methane and add Al. As a result, the IUPAC name of this molecule will become methanol. In a similar manner, a 2-carbon aldehyde derived from ethane, so replace E of ethane and add Al into it. As a result, the name will become ethanol, and in case of 3-carbon aldehyde, the name will be propanol. If CHO or aldehyde group is bonded to a chain of carbons, you have to find out the longest possible carbon chain containing aldehyde group, and then you will replace the E ending of the parent alkane to the suffix Al. If CHO group is bonded to a ring, then name the ring and add the suffix carboraldehyde to it. Number the chain or ring to put the CHO group at carbon number 1, but omit this number from the name. Apply all the other usual rules of nomenclature for naming these aldehydes. We will now discuss these rules with the help of examples. As you can see here in this example, this is a 3-carbon aldehyde. So, basically its common name should be propanol, but it is not a simple propanol. You can see here that it has a chloro substitution at position 2. So, in IUPAC nomenclature, we will name the molecule as 2-chloropropanol. Now, look at this molecule. Here you can see that at position 1 we have the carbonyl group, that is aldehyde group is at the terminal position. Then position 3 has a methyl substitution, and the longest possible carbon chain, if we number from here, it is number 1, 2, 3, 4 and 5. So, the molecule is a 5-member aldehyde. We will name it as pentanol, which has a methyl substitution at position 3. Therefore, the name of the molecule is 3-methyl pentanol. Here it is a different type of example where we have an aldehyde group in the ring. So, the name of this molecule will be, basically you can see here it is a derivative of ethanol, but one of the hydrogen of this carbon has been replaced by phenyl group, and that is why the name of the molecule is phenyl ethanol. Here in this table you can see the IUPAC names, common names and formula of some of the aldehydes. The lower aldehydes like methanol having 1 carbon, butanol having 4 carbon and pentanol with common name varaldehyde having 5 carbon. We will now discuss the nomenclature of some complicated molecules. We will apply the rules as we have discussed earlier. Look at this example. The maximum number of carbon here are 5. So, this is a pentane derivative. Replace E of pentane by Al, it becomes pentanol. Now, we will number the molecule starting from this carbonyl carbon. When we number it from here, this carbon gets number 1, 2, 3 and 4. That is why at position 4 we have a methyl group. Hence the name of the molecule becomes 4-methyl pentanol. Here we have few more example. You can see this is a cyclohexyl ring and this is a single carbon aldehyde, that is a CHO group is attached to a cyclohexane ring, and hence the name of the molecule is cyclohexane carbonaldehyde. Whereas here the two aldehydic groups are attached to benzene ring, and since the two groups are at different carbon, we have to number the groups in such a way that we get minimum numbers assigned to the substituent groups. But since you can see this is a symmetrical molecule, whether we number it from here to here or from the other side, that is clockwise or anti-clockwise, it will have 1,4 substitution. Hence the name of the molecule is 1,4-benzene dicarbonaldehyde. Now we will discuss the nomenclature of ketones. In the IUPAC system of nomenclature, all the ketones are identified by the suffix ONE. You have to first find out the longest continuous chain containing carbonyl group and change the suffix E of the parent alkane to the suffix ONE. You will then have to number the carbon chain to give the carbonyl carbon the lowest number. Apply all the usual rules of nomenclature. Simplest ketones must have 3 carbon atoms. The reason behind it is that ketone has 2 alkyl groups attached to carbonyl carbon. So, at least 3 carbons are needed for a molecule to have a ketonic functional group. The base name of the compound has to find out first, that is longest chain with carbonyl group, then replace E of alkane with ONE, indicate the position of carbonyl group by number on the chain so that carbonyl has got the lowest number. Like for example, this is propanone because it has 3 carbon and a ketonic group is over there. We do not have to give the position of keto group here, because if keto group will come to terminal position, then the molecule will turn into aldehyde. So, in case of this molecule, this is called propanone. This is 3 carbon ketone having a carbonyl group at position 2, but we normally do not give the position of ketonic group here because this is the first member of ketones. Similarly, here in this molecule you can see that if we number the molecule from this side, position 2 gets a keto group, but if I number the molecule from this side, position 3 will get the keto group, and that is why the right nomenclature is one where the carbonyl group gets the minimum number, and that is why the name of the molecule is butanone or 2-butanone. Now look at the third one. Here you can see, as we have already given the number, it is an 8 carbon alkane, so it is octane, and since we have a carbonyl group, it becomes octanone. But if we do not mention here the number of carbonyl group, the name of the molecule will be incorrect. Reason being, the carbonyl group can be at any position, like at position 3, 4 or 5 or 6, and that is why the right number here will be 4-octanone for this molecule. Again, in this example, you can see that this is a 5 carbon ketone having a chloro substitution at position 4. Hence, name of the molecule is 4-chloro-2-pentanone. We will now discuss the common system of nomenclature for ketones. It is based on the alkyl groups that are bonded to carbonyl carbon. Alkyl groups are prefixed followed by the word ketone. The order of alkyl group is alphabetical and the size of alkyl group is smaller to larger. Like in this case, you can see that we have a ketone where we have one methyl group and this is ethyl group. So, if we name it as methyl ethyl ketone, this will be a wrong nomenclature because M is alphabetically comes after ethyl. So, the name of the molecule here is ethyl methyl ketone and not methyl ethyl ketone. In this particular case, there is no difficulty because both the alkyl groups are same. So, we simply name the molecule as dimethyl ketone. Here we will compare the IUPAC system of nomenclature with common names of ketones. Common name is given by naming both alkyl groups on the carbonyl carbon, arranging them in alphabetical order and adding the word ketone, whereas IUPAC name is given on the basis of carbon chain and position of carbonyl group. As you can see here, in both the cases it is butanone. This molecule in IUPAC nomenclature is called butanone because position 2 has a ketonic group, whereas common name for this molecule is ethyl methyl ketone. Three widely used common names of simple ketone do not follow this convention. Like in this case, you can see this molecule is called acetone. It does have this methyl group, but this common name has been accepted universally for acetone. Similarly, this acetophenone is also a common name for this ketone, and benzophenone is also accepted for a common name. Aromatic ketones are named in a fashion similar to that of aliphatic ketones and often have special names as well. You can see here, this is an aromatic ketone and this is the common name for this is acetophenone. It is also called methyl phenyl ketone, but the IUPAC name for this molecule is 1-phenyl ethanone. This IUPAC nomenclature is hardly used for this molecule in chemistry. With cyclic ketones, numbering is always begins at the carbonyl carbon, but the number 1 is usually omitted from the name. The ring is then numbered clockwise or counterclockwise to give the first substituent the lowest number. Like for example, in this case you can see this is the ketonic group. If we number the bromine clockwise, then the number will come as 2, 3, 4 and 5. It will become 5-bromoacetophenone. But if we number it counterclockwise, it becomes 3-bromoacetophenone, and since we know that we have to number in such a way that minimum number comes to the substituent, the right name of the molecule is 3-bromoacetophenone. Acyl groups having carbonyl group are named as substituents. The three most common acyl groups are formyl group, acetyl group and benzoyl group. We have here some more examples of ketones. We have also mentioned the name of the molecules. It will be like an exercise for you. You can practice the names of these molecules on your own. We have few more examples. We have provided you the names, IUPAC name of these molecules also. We will now discuss the nomenclature of dialdehyde. Dialdehydes are compounds that contains two aldehyde group. They are named by adding the suffix dial. Instead of al, we add dial to the corresponding hydrocarbon name. As a result, here this is a 4-carbon alkane butane, and since the terminal positions are substituted with aldehyde group, the name of the molecule becomes butane dial. Now we will discuss the molecules where we have both aldehyde as well as ketonic group. Now here the problem arises that out of aldehyde and ketone, which should be given priority, like should we name the molecule as an aldehyde or we should name the molecule as ketone. It has been given according to IUPAC system that aldehyde take priority over ketones. So here rest of the rules remaining the same, we only have to find out the aldehyde group in the molecule and then we have to name the molecule. Like in this case you can see we have here this ketonic group, this is also a ketonic group and this is an aldehyde group. Position 3 and 4 has the keto substitution. When ketonic group is present as substituent, it is not called keto group, it is called oxo, and that is why the name of the molecule is 3,4-dioxopentanal, a 5-carbon aldehyde. We will now discuss one more example where the molecule has both aldehyde group as well as ketonic group. As in this case, we have aldehyde and ketonic group and the name of the molecule is 4-oxopentenyl. Here in this example you can see that the molecule has 2 ketonic group only, and that is why the molecule is named as 5-methyl 4,6-dioxononane. We will now introduce a problem in nomenclature at this point. Actually we call it as nomenclature dilemma. Let us say you are trying to name a molecule. You are familiar with the name of the molecule having suffix like ol or in or ain or al, on, as we have discussed so far. But then you come across a molecule which has multiple functional group. Like here in this case you can see that there is a carboxylic group as well as a ketonic group. Here also there is a hydroxy group and ketonic group. So when you have the groups, more than one group present in a molecule, then what will you do? What suffix will you give to the molecule? These are some molecules which actually are difficult to name. We need some kind of priority system for nomenclature of molecules having more than one functional group. IUPAC has developed such system of priority. If you have a molecule with say carboxylic acid group and ketonic group, then the functional group with highest priority will be the one which gives its suffix to the name of the molecule. So in the case the suffix of the molecule will be oic acid and not on, because carboxylic acids are given higher priority over ketones. However, if a ketone is present with an alcohol, then we use the suffix on, that is we can say ketones get priority over alcohols. But what is the system or on what basis we are setting the priority, we have to find out. It is an arbitrary agreement with IUPAC, although there is some correlation between oxidation state of carbon and the priority given to the group. However, this really is not an example of something you have to either look up, memorize or to have a computer to do for you. It is not a conceptual thing. So, we are now giving the priorities of various function group in the order of in the decreasing order. That is, with this priority order you can say that if a molecule has a carboxylic group and a ketonic group, then obviously the molecule will be named as keto acid, that is ketone will be a substitution in the carboxylic acid. But if a molecule has a ketonic group and say for example a thiol group, then ketone will get priority. Similarly, in case of amino group and keto group, again ketone will get priority. So, this priority order is utilized for naming some complex bifunctional compounds. Here we have given different functional groups with the prefix and suffix in the order of decreasing priority. You can see here we have given here carboxylic group, ester group, acid chloride group. Similarly, all these groups have been given as prefix and suffix. So, wherever the group of higher priority is there, this suffix will be used. If the group is of lower priority, then prefix is used. We will discuss it with the help of some examples. As you can see here in this molecule, we have taken 3 examples here. I will take only one of them. This is carboxylic group and this is ketonic group. If I number it from this side, then obviously I will say that this is a keto group is getting priority, but actually we know according to priority rule that the priority will be given to carboxylic group. That is why the numbering will be done from this carbon and not from this carbon. As a result, position 4 will have an oxo group, and that is why the IUPAC name of this molecule will be 4-oxopentanoic acid. Similarly, you can name this molecule by taking the help from the table we have earlier mentioned. In this molecule also you can see that we have an aldehyde group, along with that we have a hydroxy group and methoxy group. Now, since aldehyde group takes priority over hydroxy and methoxy, and then we have to number the molecule in such a way that minimum number goes to the substituents, and that is why we will number the molecule starting from the CHO group at position 1 clockwise direction, As a result, the name of the molecule becomes 3-methoxy-4-hydroxy benzaldehyde. Another example which shows with the help of priority order, we can name the molecule like this. Here are some examples for your practice sessions. You can practice the name of these molecules. You can take help from the earlier content we have given on the priority rule. We will now discuss the uses of aldehydes and ketones. Methanol, having a boiling point of -21 degrees, is a gas and is used in aqueous solution as formalin to preserve tissues. Ethanol is produced from ethanol in the liver, causing hangover symptoms. Propanone, also called acetone, is the simplest possible ketone which is miscible in water. It is inflammable, and both acetone and methyl-ethyl ketone are very versatile solvents. Ketones are common solvents for quick drying paints used in various applications. Like in this particular case, you can see that the paint is utilizing ketone as solvent. Aldehydes and ketones find uses in industries also. A number of aldehydes and ketones are used in food chemicals as natural food additives and as artificial additives. They are also used as fragrant chemicals, they are used in medicines, and then they are also used in agricultural chemicals. This is vanillin. It is available in vanilla beans. All of you must have tasted vanillin in the form of vanilla ice cream or vanilla essence, which contains this compound in it. Then there is the mushroom flavor is because of 2-octanone present in mushrooms. Aldehydes are present in nature in almonds. It is benzaldehyde which is present in almond, and then cinnamon is present, or cinnamaldehyde is present in cinnamon. We have here citral which is found in lemongrass. We have here this damascene which is found in berries. Now to summarize present day's lecture, we have introduced carbonyl compounds to you in the present lecture. Then we have discussed nomenclature of aldehydes, ketones, dialdehydes, diketones in detail. We have also discussed the nomenclature of carbonyl compound having 2 or more different functional groups. We have introduced you with the concept of priority rule, how the different functional groups are given priority, and lastly we discussed in this lecture the uses of aldehydes and ketones at various places. In the next lecture, we will discuss the methods of preparation of aldehydes and ketones. Some of the methods have already been discussed in the first lecture. We will discuss rest of them in the next lecture. Thank you very much.